Hi, so in this analysis, what we're going to be doing is diving into a bike sharing company data set. And what we're going to be doing is evaluating how temperature affects our riders and what recommendations we can add. But this is going to be more of visual storytelling where we use Python to create several visuals that we can think help us to convey our insights and our data story a little bit better. And what you're looking at now is called a ridge plot or a joy plot, which is a combination of different plots that we use in Python to create this image. So you can see it goes from our months January to December, and we see a distribution of temperatures. So we can see the shape of the temperatures there. And then the color itself is represented as the volume of riders in each one of those months. So it can be quite telling, and it can be a good visual to open up conversation when we are evaluating visuals. So we're going to look at all the visuals first, and then we're going to dive into the code later. And I'll show you how to create this plot. And it's not too difficult, just takes a little bit of customization. So in the next visuals, we're looking at heat maps where we have our heat map, which is going to show the month, which is going to show months and day of the week. And we can see that casual riders are more kind of concentrated at the weekend, while our registered riders, if we create another heat map, which is monthly and hourly, we can see they are concentrated at that period of time, which is more regular. So what we have here is a correlation plot where we have the correlation between all of these variables and total riders, and it's a single correlation, and we can see the gradation goes from negative to positive where we can see what the correlation is. It's a great visual. And on the right hand side we have two reg plots or regression plots where we can see the difference in the linearity between those two data sets, and then we can show that one is more linear than the other, and then also put that linear regression best fit line. Lastly, what we're going to be doing is just adding recommendations. So let's start coding. So in our Jupyter Notebook, we have our code kind of folded with this effect that you can do with your extensions, and all we're going to be doing is we're going to be doing all the data processing steps, and then we're going to analyze and visualize your data. So let's dive in. So I'm going to open up all the code, and the first thing we're going to do is load in our packages. We're going to load in pandas as PD. We're going to load in Seaborn as a variable SNS. We're going to load in matplotlib and save it as a variable PLT. From scipy.stats, we're going to import the Pearson and Spearman correlation, and I'll show you the difference between those. Also, we're going to import warnings and use filter warnings just because I don't want to constantly see the warnings. So we're loading in a bike sharing data set, and you can get this from the link below. It's a very good machine learning data set for regression and forecasting and correlation analysis, which we're doing today. So you can see that we have date time and the hour, the season, the holiday, the working day, the temperatures, the humidity, wind speed, and registered and count. And I'm just using the regular temperature here for my main column. So the first thing I did was I wanted to prepare the data. So I looked at the date types. I wanted to make sure I had a date time. I created a month column. I created a year column. I created a month number column. And then the way we do that, once you convert your date time using that pandas variable, you can use .datetime, which creates the datetime variable. Once you have that, you can constantly use this particular column to create more columns just by using the DT method here. And then strip time allows you to pass in the string times, and this is going to pass in a capital month, and this is the signification for that. And you can see I created a year by just using datetime.dt.year. Then what I can do is for the month number, same thing, .dt.month, datetime.dt.day a week. So you can see how you can keep chaining things together to make new columns. We use that string time or strip time, and then I'm going to get day of the week and not just a day number. And then all I'm doing is assigning these columns. And the last thing I wanted to do is create a total riders column, which is we have two types of riders, which are casual or registered. I just added those two together, and you can see what you get here is we get the same thing. And if I hover back over, you can see all our new columns here in the total rider column. Next, what we want to do is because our seasons, and let me show you, our seasons are just numbers. I want to be able to create a map so I can see the word for season. So when I do analysis, so we can see that 1 is winter, 2 is spring, 3 is summer, 4 is fall. And all I'm using is I'm creating a new season column by using that bracket notation. And then once I have that season column, I just map my season mapping over to that. And that will give us the strings that we want here. Now we're going to start like digging into answering some questions. So let me pull this up, and then we can see that I created a docu-string here by saying what percent of riders are registered. And all I did is isolated the registered column and summed it, and then just divided it by the total number of riders, which we see 81% of our clientele are registered. Then I wanted to know, does the registered rider percentage increase by month over time? So all I did was use a group by using that df variable that brought in our data, and grouping by season and month, isolating the registered column and summing, and then dividing it by I group by of total riders. So you can see it's just two group bys, and let me just show you like this. It looks a little confusing if I put a escape string here, which will allow us to actually have this broken up, but all I'm doing is dividing group by group by. And what that will give us, as you can see, fall is December, November, and October according to our document. And we can see that the winter months we're at 90s and 80s. For the spring months we're in our 70s. So you can see what is happening is that registered rider is going down and we're getting more casual riders. So the fall months are December, November, and October. And then the winter months are here, which are in the 90s. So you can see 90 and 81 for our winter months. So what's happening in these months is that we're getting less registered riders. And in these spring months, when the temperature and weather is nice, we're getting more casual riders. So then I said, what is the percent of riders by month? And then I just broke it up, and then we can also look at those winter months, which are, January, February. You can see that our percentage of our total riders is quite low during that period, which means that the temperature is not allowing our riders to actually use our services. So one of the recommendations that you see that I'm going to recommend is that we should offer a yearly subscription instead of them using our bikes without one. So then we can still make revenue during the months that we don't have a lot of riders because they're paying for a yearly subscription. So what is the percent of casual riders? It's just going to be the inverse of that. So you can see it goes down to 1 and 2% in the winter months, but it's around 11% and 12% in the summer months. In the way I'm doing it, I'm grouping by the month, taking the sum, isolating casual, which is our rider type, and then dividing by the total number of casual. And this format would allow you to break it down to see the percentage by month, and then I just multiply it by 100 so we can see, a whole number before the decimal. The next thing I'm doing is I wanted to know what is the percent of writers by season. So I group by season and I take the sum, I isolate total writers, and then I divide by that individual grouping of the total number of writers. So you can see winter, it goes down to 14%. And this is just another form of analysis that we did up at the top. And then we get the majority of our writers in summer and spring. So that's just extra. Next, I wanted to see the percent of registered writers on a working day. So my theory is that registered users are going to be using our bikes year round as a number one mode of transportation. So we do have a working day column that is signified with zeros and ones. So we do that we group by working day, we take the sum, and then we isolate registered, and then we divide by the total number of registered. And you can see that 73% of our registered users are using the bikes on work days. So we're going to visualize this also. Next, I wanted to create the total writers column, which I already going to show you here. I believe I already did that up at top. So this is just redundant. And I wanted to make sure I didn't have any negatives there. And then I also created an hour column here. Next, for the analysis, in the visuals, I wanted to stick to just 1 year. So 2011 was a complete year in our data source. So what I did there was I just used 2011. Then I wanted to create a mean month. So this is when we start getting into the visualization. So in order for us to create that ridge plot color, we need to have a mean month. And what I'm doing is taking the mean of the total writers. Well, I actually took the median here. It can be mean or median. And what we're doing is we're mapping that to all of the months. And you'll see what I mean here. But right now I'm checking the average just to make sure to give myself a kind of a checkpoint of where the numbers should be when I put that mean month column, and I'll show you in 1 second. So you can see we have our most in June and July, which are the summer months, and we have our least in the winter months. So I wanted to see what that median month should be in terms of this distribution of months. So first we're going to create a month dictionary also. And what that month dictionary is going to allow us to do is create the months that exist on the side of our visual. So let's look at that ridge plot and be able to kind of get a better look at what we're doing. So let me just pull that up really quick. So you can see this ridge plot here. And what the ridge plot is allowing us to do is the mean month is going to be the color here. And then I need to create this month listing, because when you do sometime when you do facet grids, you're not going to get the months like this. So that's why I'm creating a month dictionary. So let me show it to you. So the first thing we're going to do is we're going to generate a color palette. I chose a seismic color palette because it goes from red to blue quite quickly. And you can see I had the number of colors. I need 12, and we don't need that extra comma. And that's using the Seaborn S&S color palette, passing in the palette seismic, and using 12 colors for that sequential color. Then I wanted to use facet grid, because facet grid allows you to make a matrix of different visuals. So I'm going to just pull this down so you can see it. And you can always press enter at commas, and this will allow you to format it. So I'm going to create a facet grid, and if you're used to Power BI or other type of documents, you know this is called a small multiples, so you'll be able to make multiple visuals. And that's when we're going to have, when we have those multiple visuals, that means you're going to have all these small little distribution plots. So then I'm going to make the hue or the color our mean month. And I'll show you that in a second. I probably should show you that, what it looks like here. Let's see if I can do that. If I've already run this, we should be able to see the head of our data here. And yes, I've run this. So when we talk about that mean month, you can see what I've done is I've taken the mean or the median and put it next to the particular month. So you can see the mean for January was 47. So I was able to map that to the actual month here in our month column using this group by and map. So let's go back down. Let's continue. The next thing I want to do is create those KDE plots, which are the plots here, these distribution plots. Then all I wanted to do is make sure they were filled so we could have the color. And then I wanted to create one without filling so I could make these outlines. So it's just two plots layered on top of each other. Then here's the hard part. When we get to the facet grid, we need to make the months exist on the left side. So for every one of those months in all of our axes on the facet grid, I said, okay, give me the axes. And we use enumerate to go down 1, 2, 3, 4, and 5, 6, 7, 8, 9. Then I wanted to pass it the text, but I wanted the text to be away from the graph. So that's why I use -25. And I wanted it to go to 0.2. And then I'm using month dictionary, where every time it loops, it goes 1, 2, 3, 4, 5, 6, 7, 8. And I want it bold in font size. So that's when we get the January, February, March, April. It's looping through, dark, and then bolding those. And making it farther away with that -25 away from the actual visual. So then I just adjust the size where they kind of overlap. And then you're using this G. And then G is what we're saving as a facet grid. That is so we don't have to keep writing SNS facet grid. We can just save all this as G. And that's when we can use other functions such as subplots and subplots as adjust to make it overlap. And then once I have that G, I can take off the spines, I can take off the Y ticks, I can despine it, I could make X labels and Y labels 0 because we want that graph to look very clean. And then we can use this to set the font sizes. I set the X label temperatures in degrees Celsius, which we don't really, is at the bottom for the X label, which is here, temperature in degrees Celsius. And then the subplot I want is what you're going to get under the title. And it says temperature distribution and writer aggregation, which is bolded. And you can see that here. So it's a quite interesting plot. I think it's quite striking, and it will give you a lot of good information to pass on and stimulate conversation to your readers and your users. So you can see what's been produced is this. So it's quite clean, and all of it's here. You can change the colors, all that kind of stuff. You can change the background, but I just thought this was the white background and the red to blue seismic sequential colors look nice, and it kind of fit very nicely with the temperatures. So let's evaluate correlation at this point, and this is where we're going to start digging into building those correlations that we saw. So I just created a function. We use a function. We can call it DEF, and then we name the function. So I called it correlation matrix. My correlation matrix is going to take data, 1 column, 2 columns, 3 columns, 4 columns. And then I use 2 types of correlation, Spearman and Pearson. Now, Pearson is more for strictly linear correlation, while Spearman is used for, you know, kind of a little bit non-linear correlation. So you would have non-linear elements that you would want to be picked up. And what I'm doing is when you use Spearman's correlation, you get the correlation and you get the p-value. So I just want the correlation. So this is why I'm using 0 after that function. I'm passing in column 1, column 2, column 3, column 4, and you'll see how that works. And then I'm saving it as a correlation here so I can make it into a data frame or series. So once we have those correlation 1, 2, 3, 4, and I put SP here, but this actually should be called PR, but I got a little lazy there. You can call it whatever you want though. And then what I wanted to return is a series. So I want all of these so I can see them. So my function is called correlation metrics, and you can see it's correlation metrics here. I'm passing in our data frame, which we saved as DF. I'm passing in registered intent, casual intent. And that's going to be what is correlated between these two. So you can see registered correlation, which is Spearman. And this is what we're returning in this series. And you can see all I did was pass it a dictionary and say the column name or the key name is going to be registered in Spearman, and then taking this correlation there. And then we can just continually do that. And you can see for registered, we get 0.39, but Spearman, we get 0.60. This is telling us that as temperature increases, we don't see a lot of correlation compared to casual, which we see when the temperature increases during those summer months. We see that linear regression line go up. You can see this for casual for Pearson, which is more linear. Spearman means it's we have non-linear elements, which would make sense because just those couple months in the summer, we see a big boost. So then I said, okay, I want to see a correlation plot to make sure that heat or temperature is what's being correlated. So all I did was pass in the correlation function next to the data frame and put the line widths here into a heat map. And we can see if we kind of isolate our total riders, which would be somewhere in here. A total riders, you can see what is highly correlated, which is you can look at the color bar here. So the things that are highly correlated are going to be more white, hot colored. So if I look at total riders, you can see it's definitely got total riders is going to be the most thing. But you can see temp and the other type of temp, atmospheric temp is there. And then the other parts that are here. But let me show you this. We'll be able to see this a little bit better by using a correlation plot, the same as we did before, but I wanted to not use all of the features that are here, and plus I just wanted to isolate total riders. So I just changed the figure size here. I use heat map, I use the correlation function, and then what I do is I pass total riders in double brackets, which will allow us to just isolate total riders. I sorted the values so that we can go from lowest to highest, and I wanted to sort it by total rider correlation. And then I dropped total riders, count, ATemp, registered, casual, and year, because I didn't care about those. I just want to see what the temperature and the weather elements, how they correlate with our total riders. And what we get is this visual. Let me zoom out just a little bit. So we get this visual where we can see that correlation increases as you go down. You can see temp, and we can actually change the type of correlation by using, I'm going to shift in tab. You can see you can use method. So we can use Spearman or Pearson correlation with this. And you see by default it's the Pearson correlation. Next, after we do this, I wanted to create some scatter plots. So let me zoom back in. So First, I wanted to pass in the correlation as a label here. So I just rounded my correlation using the Pearson correlation that we use in our function, and I pass it temp and registered, and I only want to get the last 2 decimal points. I isolated the correlation, not the p-value, as 0 because it's the first in the list. And then I use a reg plot that's from Seaborn, and I pass it my data. I say I want to see X and Y correlated, which are temp and registered. And then you can use the scatter keywords to change the edge color. I changed the edge color to white so you can see the white edge around all those little dots. And then I layered on temp and casual correlation. And then all I did for the label is pass in these rounded correlations. And this is what I got. I didn't like it. I didn't think it was very telling. I think it was too much going on in the graph. So what I did is I isolated each one of those. Same thing, just changed the keywords here, the line keywords. And then this is what I got for registered. And this is what I got for casual, which I thought was a little bit more telling. Next, what I wanted to do is I wanted to create our heat maps, which gave our indication on where our riders were. So I used a cool warm C map for this, and you can see that blue and red. So we can use SNS.heatmap, and then I created a pivot table where I wanted the data that was greater than 6 because we didn't get riders until 6 a.m. I used the index for hour here. And then I use for columns, I use the number of months. And what I did was pass in the column was month number, and the values are registered. And I use the aggregation function as mean. And then what we get is we get the aggregation here. We can see that those months have a lot more users in, and it's a little bit used here. So we could definitely, this is using registered riders because I already knew that registered riders were more stable during the year. And then you want to pass in this labeling, and you can pass that in with the X ticks. And you can see I just took the months from my data frame and just took the unique ones and passed it in with set X tick labels. And one thing you need to do is save this as a variable because you need to use set X tick labels, and the only way you're going to be doing this is saving this as a variable. So I saved it as AX as axis. Then I just changed the rotation to 7 degrees where I can see them like this. I did the same thing, created a pivot table for this, except I used casuals and I used a day number, so day of the week, and I passed in the X labels as Monday, Tuesday, Wednesday, Thursday, and Friday, so I could show that, our casual riders were weekend warriors, where they just came and did everything on the weekend. So that allowed me to create that visual. Then I wanted to make sure the percentage of casual users, I wanted to validate that, so I grouped by day a week, took the sum, isolated casual, and divided them by 2. Divided by the total amount. And you can see that 50% are on Saturday and Sunday, so that's when most of our casual riders are coming in. I just kind of wanted to double check the distribution here. This is not used in our presentation. It's just a KDE plot just to see the distribution of casual to registered, so we can see most of our casual are around this, 100 and below. Then what I wanted to do is understand what temperatures were we getting the most riders. So I wanted to do is create temperature buckets, and you can do that with the Pandas Q-cut, which creates quartiles. And then what it does is create quartiles there. And if I just show you the head of the data, so df.head, so we can see the top data. If you want to see what those quartiles look like, you can see what happens is it makes those temp buckets here. So 2 to 13 is one quartile. So what I can do is look at those 4 grouping and say, okay, the majority of our customers are in these buckets. And then you could do value counts, and you could also normalize equals true. Should be able to show us the percentage, and you can see it's going to be pretty evenly split because that's what we want it to do, is split them all up. But that's not the purpose. We want to use these as ways to get the averages for these buckets. So what I did is I created a grouping where I grouped by the team buckets. I took the mean of the casual and registered riders, and then what I wanted to do is take the difference of registered over casual to get the amount of change. So I created the first, what I did is create this little, data frame here. We have our temp buckets. We see what the mean is for casual. So you see we have very little riders for casual when the temperature is below 13 degrees. For registered, we still have 66 when it's below 13 degrees. The total riders, you can see the distribution. But you can see the difference between total casual and registered riders is 12 times. And we can see that means that our registered riders are happening a lot more during those winter months. So we can use that difference as an evaluation metric to see, okay, when it's under 20 degrees, the difference is only about 5 times. When the summer months, which would be maybe a little bit, not the summer, maybe spring, we're looking at below 26 degrees and above 19 degrees, it's only 4. But then those hot times is only 2. So we know that our casual riders are very much affected by our temperature changes. And then I just made this visual, which is just took exponential change in riders by temp group. I just created this in a bar plot. I took our grouping here, which I saved as a group, and I just plotted the difference here as Y and took the palette cool warm, and you could see this is exactly what we just discussed. So if we jump back over to our kind of presentation, and I'm going to do this presentation from the beginning. So let me do a slideshow. So let's run this from the beginning. So it's exactly what we went over. 12% of the riders occur in winter months, 10% registered, and only 2% casual. Up to 90% of riders in winter are registered. So the idea is to offset the winter plunge with subscription plans, which we can offset, the revenue plunge during those areas. And we use the ridge plot to kind of highlight all of that. Then what we wanted to do is use those heat maps to show that most of the casual riders are occurring on the weekend, and then that we're getting more stable riders from these morning hours also, which are commuting hours, which are 8 a.m., and then the 5 and 6 range. And we know 73% of our riders are using the bikes on the working day. Then what we wanted to do is statistically verify that our correlation, that heat and the day of the time of day, which we saw at registered riders, 8 a.m. and 5 p.m. That's why it's so highly correlated there, 0.41, and then 0.545 for total riders. However, if we look at linear and nonlinear correlation, we get 0.45 and then 0.60 for casual riders, which is highly correlated, because we know here, if we look at the casual riders, we can see that regression line adheres quite well, and then you can see that we get a pop-up of that data shape changes, which kind of indicates that nonlinear correlation is saying that there is something like the winter months that are suppressing the shape of the data, but then we get to the summer months, we get the pop. And then we can see the correlation also here is much more stable. It's not as linear, because we can see there's a pretty tight aggregation of all those points. So it's less linear in a sense. So then what our recommendations, we create a subscription model for registered riders, schedule staff and resources around temperature and seasons, which is kind of a no-brainer to save money. Create weekend rental package to attract more casual riders. And then next step for us would be create a forecast model to predict the demand for the next year, optimize our resources and consider any weather anomalies to also optimize for for our writers. So this is just a quick and easy way to visualize using Python visuals that I think are quite striking and quite telling. Please leave any questions or comments below. I hope you like the ridge plot. I really like using this plot. People like to talk about it. But if you would like to like and subscribe, it really helps the channel. So don't hesitate to do that or ask questions or share the video. Thank you.